Hi everyone, I'm Matty Smith with the Stanford Digital Economy Lab, and we're here to talk about a new piece titled Democratizing Statistics, How AI Can Empower Everyone Without Causing Disasters. Joining me are the authors of the piece, David Levine, professor at the Haas School of Business at the University of California, Berkeley, David Nguyen, research scientist at the Stanford Digital Economy Lab, and José Ramón Enríquez, postdoctoral fellow at Stanford University. Thanks so much for joining me, guys.
Matty.
Hey, Matty.
Hi, Matty.
Let's start by getting a bit of your background, your expertise, and talk about how this whole project came together.
I'm a computer science undergrad from many, many years ago, and I've been a professor of business where I've used statistics, but also taught statistics. And now I'm using AI and also teaching how it can go wrong. And when I was talking with David and Jose about some of their research, we were thinking about all the exciting upsides and the really predictable disasters that are coming in the next few years as more and more people start using these exciting tools.
The three of us met when Jose Ramon was presenting some new work at the AEA meetings last month in San Francisco. So we have some new work on using large language model agents for generating survey responses. And that's some work coming out of the Digital Economy Lab with Eric Brynjolfsson and Sofia Kazinek. And basically, David had lots of great comments for us, and we sat down afterwards for lunch and then started chatting about, the potential, upsides of LLMs, and specifically then thinking about statistical analysis. And it was his idea then to maybe sit down and write something in that regard that we could, that we're now discussing here, and we jokingly called StatGPT on the day already.
How would you pitch StatGPT if you want to give kind of like the brief, quick rundown? You're in an elevator with someone, they're wondering what this piece is all about.
For generations, statistics has been done by specialists. And now with these exciting new tools, ChatGPT and Gemini and all their peers, lots of people are going to be able to analyze data. And whether you're a nurse or a store manager, running a union or a church, you're going to have these powerful tools. But everyone who's done statistics knows that it's hard. It's easy to get it wrong. And if we give people these powerful tools without guardrails, without training, without human checks, we're going to see enormous mistakes being made.
AI has the great capacity to level the playing field, but at the same time, it can introduce some risks and challenges for people to how to interpret the new technologies. And even the new technologies may not be designed to take into consideration this kind of challenges that we see nowadays. And in particular, I'm referring to how people might misinterpret the data or misunderstand what the output of this generative AI models are. And this can be a huge risk as it can amplify biases.
In the worst case, the language model literally creates fake data. And we have a tragic tradition of fraud in many of the sciences. To automate that without the person even knowing it's happening would be both a tragedy and a comedy. And we know these hallucinations are possible. So we need the software to be smart enough to check these familiar problems. So hallucinations are something fairly new to the language models or conscious fraud. But the other problems, not understanding the data, those happen all the time. And that when I'm working with an advanced graduate student, they're very often not going to understand the data. In my own research, I had somebody who was 999 centimeters tall, 30 plus feet. And that was in a data set where 4 nines meant missing value. And this person was 3 nines. So obviously it was a typo. But if you don't look for those sorts of errors, you're going to end up with complete disastrously misleading results. And historically, we had to train the students to do that, and that makes a lot of sense. But what's wonderful about these language models is we can train the language models to do that as well. And so if the user is not a sophisticated user knowing to look for these problems, it can say something like, you're measuring height and you have somebody who's 30 feet tall, 999 centimeters, that's probably a typo. Should I drop that observation? So that's the sort of problem we expect as we have unsophisticated users, but also the solution. We have this incredibly powerful tool that that doesn't need to just write software to calculate what the user asks, but can actually ask the questions, do the explorations the user may not know to ask.
Yeah, I thought it was really interesting when you talk about the sort of the relationship between the user and the AI and the back and forth. So to what extent does it become the AI's responsibility then to sort of take care of the user, to teach them versus just doing the job for them?
Our business requires to constantly make decisions. There are just too many degrees of freedom on what we do, particularly when we pursue research. And a key aspect of science is to be very transparent about the assumptions that we make and the steps that we take in order to get our result. So we, in particular, are not pushing for AI models to teach the user itself, but to be fully transparent and to flag this type of inconsistencies that might happen when a user, a not very sophisticated user, may try to do something that seems a little bit funky for the model. So we want those assumptions to be fully transparent and that the user can decide after all whether it's they are going to take the decision by the model or not. Apart from that, there are obviously very powerful tools out there, Coursera, Harvard X, the Khan Academy, for instance, where they have been pushing for increasing literacy in all types of domains, including data literacy. So these are not mutually exclusive, and I can imagine a world where there are going to be AI coaches for data, and they can give you lessons where your input is going to matter for them in the way of how challenging the next question is going to be. So some sort of feedback loop between you and the model, and teaching you how to use data, also teaching you languages or any other topic really of interest of the user.
And
And
let me agree.
maybe
I'm sorry.
no, let me add one quick reason on this. I fully agree with you both there, but the reason why I think this is really pertinent to discuss now is just look at if we look at the adoption rates of large language models across different disciplines, across sectors, etc. You can see people are using them a lot to summarize text, to kind of summarize data. We started seeing a lot of people starting to use the tools to visualize data. So the natural next step will be that people will, use large language models to also jump into more advanced statistical analysis, causal inference, etc. And that's why it's really important to now lay the groundwork for some, either a co-pilot stat GPT type tool that kind of oversees what you're doing, or to build in certain safeguards within the system already that can make sure that we do not commit any fraud, whether that's willingly or unwillingly.
And I don't think having a coach versus a teacher, that those are two choices. That when it coaches you, you're learning if it's done well. And so when it says you have this unlikely value, we hope that helps the user learn, hey, I should look for unlikely values or illegal values in other data sets. That if you're looking, how does education predict wages? And it says, remember, not all correlations are causal. It could be that a rich family both has educated children and rich children, but the education didn't cause the child's prosperity. Family prosperity caused both. And so it's coaching in this example, but I hope it's also teaching a general principle so that the user becomes a more sophisticated both producer and consumer of statistics.
You also talk about the idea of having either additional software to implement these features that would mitigate risks. Ultimately, it feels like you conclude that that initial AI tool, having it incorporate those features from the start, is ideal.
I don't believe that, one should exclude the other, right? I think we can really have both here. It should be a collaborative approach. Certain things can be built in, other things can be, external tools. It's a little bit like when humans do research together, right? We work in teams, so you have certain levels of expertise. You're really good in one thing, someone else is really good at another thing. So I imagine, we have a collaboration of like humans and different types of LLM-based tools that can think about what are the statistical biases, what's the problem with the data, what's certain causal inference issues that are pointing here. So I see this more as a collaborative kind of effort, and not necessarily something that's fully built into the original model. I think a collaboration is the better approach.
And let me disagree at the margin. Every approach of improving the quality of analysis is needed. But I really do want a lot of this built into the models that consumers see, that users see, because the least sophisticated users are the ones who won't know they have to get the quality control software or Copilot or whatever. So ideally, when the language model realizes it's doing a statistical analysis, it automatically either adds to the prompt or adds a referee agent to check its work, but that this happens without the user needing to know that they need to ask for it. At the same time, agreeing with David that it'd be wonderful to have a separate set of tools that also did the quality control, because it's hard to do it right. There's an endless number of ways to do it wrong. So it's good to have lots of AI and ultimately for important decisions, humans in the loop checking the work.
And thinking harder about the house, there's a very promising area of research currently and also system development, which is called agentic models. And the idea is having these adversarial systems where they would ask the other system to replicate data, for instance, or follow up questions on the particular decisions that the initial model made. So this could be a really good way of trying to integrate that part of dealing with unstructured data, in particular, having made the model certain decisions and actually have them replicate. Hopefully, these models are diverse enough so that they're not systematic risks of doing this, and that certain errors do not fall into the cracks. But in general, I think as a field, we're moving into these adversarial models that can be used not only for statistics, but they have been currently used for also even democratic deliberation.
There are two sections in this write-up. One is on statistics, and the other one is in AI-led coding. What made you want to bring those two together for the same piece?
Well, I'm not sure they're one piece, but I think they have this parallel, truly exciting, empowering ability that anyone who envisions a video game can create it, whether they're a high school student or a baker or a farmer in Uganda or whatever. That's really exciting. But as the software is starting to make important decisions about how long an oven will run or where we're going to plant these seeds, and my livelihood depends on it, we have to realize what every coder learns, which is writing good software is really hard, and that programs rarely work. It's really hard to get a program to work. It's much more work to get it to solve a problem than to write software that does what you thought you wanted to do. And the difference between being a coder and solving a problem is enormous, because it means you've checked whether the code does not what you think you wanted to do when you started, but that it actually solves the broader problem you had in mind. And anyone who's done software engineering knows as you write the program, you understand the problem better. And as you see the bugs that arise, you're going to end up with a very different output than what you started. Writing the initial code is a very small share of solving a problem, but people won't understand that when they get excited about being able to describe an image, you get the image, describe a game, you get the game, describe an optimal way to allocate my cooking, and you get a plan for how to do your baking for the day. It looks like it's addressing your problem, but it's really just a very lousy, rough draft. And it's not the fault necessarily of the artificial intelligence. It doesn't matter how smart it is. It's because in the process of coding and testing it, you understand the problem better. So in the short run, the software won't run that often. And we see lots of this AI software is got lots of bugs in it. that will get better pretty quickly. But the bigger bugs that the program does what I asked it to, but what I asked it to doesn't really solve my problem is much, much harder. The famous quote is something like, it's hard to make things idiot proof because idiots are so creative. And so creating secure software is terribly difficult. And the idea that naive coders giving instruction are going to get secure software is completely impossible. So again, we can have an extra layer that people request, but the most naive users won't know to request that. So the sorts of adversarial agents that Jose was describing, it's crucial they be built in automatically. That when you see we're writing software, it tells you what are the likely ways to fail, and helps ask questions to the user to understand not what they think they want to do, but the broader context of the problem. So it can understand whether this code is actually going to address the broader problem.
I would say one thing that the two pieces, the one on statistical analysis and one on coding, have in common is probably that, fundamentally the technology here is lowering the barriers to entry, right? It makes it much easier for people to get into statistical analysis, makes it easier to get into coding and then progress while you're there, right? So that's kind of the starting point for us to look into these two adjacent areas, even though they have their own, set of problems beyond that. But there's also similarities, like, for example, over reliance in terms of, what the system automatically does for you, right? And there has been some studies showing that, if you rely too much on the output, you might actually lose certain skills over time. And anybody who's kind of engaged in data analysis and coding, etc., before knows that after a few weeks and months, if you haven't done a certain thing, you will actually not know how to do it anymore. You will know where to look it up, but this also takes a lot of practice. And I think one of the fears that we would have here is that if we rely too much on certain tools, then we might not only not see some of the pitfalls, but also lose certain skills over time if we rely too much on them.
Piggybacking on that, I guess one of the main goals of the piece is that the only way to really increase productivity in low skilled users is making sure that this type of mistakes can be avoided at all points. And that is also a good solution for propagating more innovation and real diversity. If users truly understand what the models are capable of, then they could avoid common mistakes, and then they can move ahead of what the model actually produces and the common answers that the model produces, so that they can apply whatever their skills are to the particular problem at hand.
We want these software agents, artificial intelligence, language models and all, to be assistants, but they're coaching you, they're teaching. They're not just replacing skills. They may be replacing some of the grunt work. Remembering where a semicolon goes is the reason I had to leave programming myself. But that they're teaching the deeper principles, whether in statistics or programming, so that people end up with a richer skill set, able to solve more problems, not solely reliant on the language model, but really learning to become problem solvers, not just coders, not just data analysts.
I'll end on this question for all three of you. This is really just for you personally. Now, you all have a lot of experience with statistics. Do you see yourselves at a point completely trusting an AI to do your data analysis for you?
As a good scientist, I would say yes, but it depends, I guess. So I think, as with, anything where you start trusting over time, this is a process, so it'll be gradual. I think over time we'll start trusting the LLM with certain tasks more than other. We're going to start understanding what they're good at, what they're not good at, and then over time, place more trust into them. I think ultimately, if you have the right level of transparency, collaborative tools, we can have, independent auditing and benchmarking of some of these tools, and they're fully transparent and open source, then I think, yes, I would see myself eventually to trust it with fully automating certain statistical analysis for me.
It'll be a process. If I have a very simple data set and I say, what's the average grade point average of the freshman versus the sophomore? In 2025, I still wouldn't trust the agents. I hope in 26 I would. That's very different from saying, go get the right data. I don't even know what it is. And then explain to me the relationship between this and that. That is not going to be in 2026 or 27. But as David said, it's a dream we all share. But I think for any analysis, even done by very advanced colleagues of mine, you do like to see the result built up from the pieces. And so even if I'm not inspecting the code or looking at the data myself, I'll always want to see how the pieces come together to tell this story. And so part of what we want is artificial intelligence, just like any good researcher, that doesn't just give you a black box, but shows you piece by piece how the data tell a story that isn't just a black box, but can explain the logic of the software and why it's doing a good job of optimizing this bakery or this farm or whatever else the decision is.
To me, this is a hard question as very similar to whether I imagine in the future that self-driving cars are going to be everywhere and everyone is going to forget or they're going to stop learning how to drive. So maybe eventually that's going to be socially desirable and everyone will be better off if that happens. But still, until we get into the point to which we can code only using natural language, we should be very well aware of what the decisions are built into the models and to ask for transparency into what the outputs are.
Awesome. Well, David, and Jose Ramon, thank you so much for joining me. I really appreciate your time and your insights. And if anyone wants to read more, the piece, Democratizing Statistics, will be available on the Stanford DEL website at the link accompanying this video. Thanks so much, guys.
Thank you very much.
Thanks, Matty. That was fun.